I'm sure you've looked at a histogram, and on the y-axis, the vertical axis, you've seen different numbers. We can represent the heights of the bars, the rectangles, to be either frequency, probability, or density. In this video, I want to show you the differences between those three types of histograms. And I've opened a brand new Mathematica notebook. Please bear in mind this is not about the code. You can ignore the code completely because you can do the same in R, Python, Julia, many other languages. So let's look at a histogram. Here we see a depiction of a histogram, just a little bit of the anatomy of a horizontal histogram. By horizontal, we mean that the observations, the values for our random variable are on the horizontal or x-axis. And then we divide this interval. You can see from the lowest value to the highest value, we divide that into sub-intervals called bins. Now these sub-intervals, that's really just a lower value and an upper value within that little sub-interval. We're just trying to express something about the values that are between that lower bin value and that upper bin value. And that happens for each of these rectangles. Now the information that we want to convey on the y-axis, that's the height of each of these bars, each of these rectangles, that is a decision that we have to make. And then in this video, I want to show you three different types of information that we can display on that y-axis. That is the frequency, the probability, and the density. Now throughout this video, I'm going to use a bin width of 10. That means if I look at any of these little rectangles, these little bins, that if I take the upper bin value minus the lower bin value, I'm going to get a fixed difference of 10 units. So let's generate some data. Of course, as I mentioned, please ignore the code. You really don't have to look at the code if you want to do that. I've put some code comments. You see the light blue color, that's the code comments. And you can read those to give you a little bit more insight into the code itself. Now I'm going to generate 1000 observations of a random variable x, and that x is going to be described by the normal distribution. Remember, a normal distribution has two parameters, a mean and a variance, and I'm going to choose a mean of 100 and a variance of 100. So I'm going to execute this code and we'll see 1000 observations. Look at all those values. Now let's look at the different histograms that we can create. We're going to start with a frequency. So in this first line of code, what I'm going to do is look at a little bin that is between 90 and 100. So if I look at the 1000 values, I'm only going to select those that are on this interval from 90 to 100. Now this interval that I use here is left closed, right open. So 90 would be included, but 100 would not. But x here is a continuous random variable, so that choice is really not that important. And let's execute and see how many values of these 1000 fall within this little bin from 90 to 100, and we see 350. Now choosing the frequency on the y-axis or the vertical axis will tell us this information. On that little bin, the height of our bar would be at 350. Let's look at this histogram. There we see the histogram. There's our bin from 90 to 100. And I've depicted this frequency or the count at the top of each bar, and indeed we see 350 of these 1000 observations were in this interval from 90 to 100. Now do mind, this is a count and it's an artifact of my decision on my bin width. If I made the bin width anything different than 10 and I set the lower and upper limit of each bin differently, I would get a different frequency. It's just telling me between 90 and 100 of those 1000 values, we found 350. And that makes it really easy for us to think about the probability, because the probability is this proportion. So now I want the height of these rectangles to demonstrate what proportion of those 1000 observations were within a certain interval. So once again, I'm going to take this little interval from 90 to 100. I'm going to count them. We know they're 350, but now I'm just going to divide by the total number of observations, which was 1000, which means the proportion of the 1000 observations that were between 90 and 100 was then 35% or 0.35. So if we generate this histogram, now look at the y-axis. It is now telling us the probability of finding a value, that is the proportion of the values of those 1000 observations that are within each of our little bins. So what that 0.35 would indicate is if I were to select one of the random observations from the set of 1000 observations, there would be a 35% probability that this value I select would be between 90 and 100. The last type of information that I'm going to talk about on this y-axis is density. So what we're going to do is we're going to take this proportion and we're going to divide that by the bin width itself. So what I've done with the code, we see the proportion, I'm just multiplying that by 1 over 10, which means I'm dividing by 10 because my bin width is 10. And now I get a density of 0.035. Remember, all of these values are dependent on your choice of the bin widths. Now let's create this histogram, and now you can see the y-axis is different from before, and what it indicates now, the heights of each of these rectangles is just a height. And if I take the geometric area of every bar, of every rectangle, I do the height times the width, I would get the probability of taking a value at random from this 1000 and finding it within that specific bin. So this bin width is 10, and if I look at the height of this bin that we've been talking about, that's 0.035, I multiply that by 10, now I'm back at a probability, and that's why we call this a probability density. And the result of all of this is if I take the geometric area of each of these rectangles and I sum them, they will sum to 1. And that should make sense because probability density functions are graphs for which the total area under the curve is 1. That makes it a probability density function. And that's what we can see here as far as being very precise with our little bin widths, is if we choose density, we're going to have a total area of these rectangles to be 1. So I hope this has given you some indication of what you would expect or why you would choose either frequency, probability, or density for your y-axis for your histograms.